We can also be asked to use Pythagoras to find a shorter side, but in a context. So just like we did with Pythagoras to find the hypotenuse, we're going to look at some context-based questions using Pythagoras to find one of our shorter sides. So this question here asks us to find the area of the rectangle below. And usually when we were doing area questions, we would do area equals length times breadth. But the problem here is that we don't know what the breadth of this rectangle is. But what we can do is we can split this rectangle into two right angled triangles, so splitting it right down the middle. Use Pythagoras to find x, and then do 20 times x to find the area. So what I'm going to do just down here at the bottom is I'm going to draw a right angled triangle, just so that I've got a shape that's separate from the main diagram. So you'll see from my examples, and you'll know from the ones that I've done with the class as a whole, that these do not need to be higher art standard. Okay, I do not need this to be perfect. It doesn't need to be, shaded and rendered. It doesn't need to be drawn to scale. It doesn't need to be even drawn using a ruler. We're just going to do a quick triangle and then label on what we know and what we're being asked to find out. So I'm going to quickly label the sides. So the hypotenuse here is 25, our C. A is x, what we're trying to find, and B is 20 metres. So now I'm going to copy down the formula and substitute in what I know and what I'm being asked to find out. So A squared, remember we're using this version of the formula, equals C squared minus B squared. So x squared equals 25 squared minus 20 squared, which when you put that all in your calculator gives you 225. So x is the square root of 225, which is 15, and always remember your units, 15 metres. Again, we've not answered the question because the question asks us to find the area of the rectangle, and all we found is that this side here is 15 metres. So we're going to borrow again from our previous topic, where we know that the area of a rectangle is length times breadth. So area equals 20 times 15, which is 300. And remember, our units for area are square metres, and that's your answer. So always make sure with these questions that even though it's a Pythagoras question, that you're actually answering the question. Don't just do Pythagoras and then leave it at that. Actually answer the question that you're being asked. The second example, when we're looking at context questions to do with finding the shorter side, is this example here where we're asked to find the perimeter of this isosceles triangle. We can see that it's isosceles because we have these markings on either side of the triangle, which tells us that this other side over here is also 26 centimetres. So again, another example where we don't have a right angled triangle that immediately jumps out at us. So I'm going to draw one. And where we're going to find this right angled triangle is by splitting the isosceles triangle down the middle. So here, where we have the 13 marked on, we're going to split it down the middle. We know that this side here is 13 centimetres. And we know that the sloping side is 26 centimetres, because that's just this side here. And what we have to do is find this bottom part, which will tell us the distance from here over to here. So first of all, I'm going to label the sides. So I'm going to label the hypotenuse C. I'm going to label the side that we're trying to find A, and 13 centimetres as B. So if we go to the formula, A squared equals C squared minus B squared. Just going to keep it as A squared. We don't have another letter to put in place of it. I'm just going to say A squared equals 26 squared minus 13 squared. Work that out in your calculator. And that gives you 507. So if a squared is 507, then a is the square root of 507, which gives you 22.5166, blah, blah, blah. We're going to round that to 22.5, and that's in centimetres. Again, we have to ask ourselves, have we answered the question yet? And no, we haven't. So what we need to do is find the perimeter of this shape. So what we've worked out is the distance from here to here, which is 22.5. But what we also need to factor in is the fact that this bit over here is also 22.5. So when we're adding all the sides together to get the perimeter, remember when we actually did perimeter, I said imagine that this is a park or a field or something. Imagine that you are standing at one side. Imagine this is you. We'll draw a wee person. And you've got to walk all the way around it and trace your finger or your pencil around the shape to make sure that you incorporate every side. So we have 26 and then another 26 and then two lots of 22.5. This 13 isn't included here because it's not part of the perimeter. It's the height of the shape, but if you were to walk around that shape, you don't walk across the 13. So we're adding together 26 plus another 26 plus two lots of that 22.5 that we've just worked out. So the total perimeter of the shape, or this isosceles triangle, is 97, and it's measured in centimetres.